Lesson 5.5, Factor Expressions. In this lesson, you're going to use common factors and the distributive property in order to factor expressions. And that's your I can statement that you see here. Take a look at the explain it question. Tasha is packing gift bags that include the same items. She has 72 glow sticks, 36 markers, and 24 bottles of bubbles. Tasha believes that she can pack no more than 6 bags using all of her supplies. A. Do you agree with Tasha? Explain. If Tasha creates the greatest number of gift bags, how many of each item is in each bag? Explain how you know. Go ahead and try to explain this question, parts A and B, and then come back and check your responses against mine. For this question, I don't agree with Tasha. She can actually make more than 6 gift bags. So if we look at the number of items that she has, 72 glow sticks, 36 markers, and 24 bottles of bubbles, we can see that just making 6 bags is going to give a lot of those items in each of the 6 bags. However, she can make a total of 12 gift bags because we're looking at what is the greatest common factor of 72, 36, and 24. Each of them has a factor of 12, and what you multiply by 12 to get each of those numbers will tell you how many of that item would go in the gift bag. Now take a look at the bottom. The bottom has a focus on math practices. It says Tasha added more markers and now has a total of 48 markers. Okay, so markers, it used to be 36, now she's got 48. Does this change the possible number of gift bags? So think about that. If I change the number of markers from 36 to 48, does that change the greatest common factor of 72, 48, and 24? And the answer is yes. Now she can make 24 gift bags because when she makes 24 gift bags, she will have fewer items in each gift bag, but she can make more. So in this case, yes, it changes. Okay, she can make 24 gift bags, and in each gift bag she will have 3 glow sticks, she will have 2 markers, and she will have 1 bottle of bubbles. All right, now let's go on and look at example 1. The essential question for this lesson asks, how does the distributive property relate to factoring expressions? And that's the question that we aim to answer in this lesson. So let's take a look at example 1. Factor expressions. Kiana painted a rectangular wall blue to start an ocean mural. She used 3 cans of paint, each of which covered X square meters, and a different sized can that covered 12 square meters. What are possible length and height dimensions of Kiana's mural? So we're going to use a model in order to determine how we can picture what's happening in this problem with the square meters that the paint will cover and the size of her wall. So you can see from the picture here on the right side of the page that she has the X square meters, and there's 3 cans of paint there, and then there's 1 can of paint, a different sized can, that covers 12 square meters. So the expression 3x, which represents these 3 paint cans here that all cover X meters, plus 12, and the 12 represents the other can over here, represents the area of the mural. So one way to use an area model to represent the area of the mural is the expression 3x minus 12. Now, we need to find the dimensions of that mural. So one possible set of dimensions of the mural could be x plus 4 meters long and 3 meters tall. Remember that the area model means the area, which is the length times the width. Okay, so one of those dimensions is 3, and the other one is x plus 4. The area of that wall would be 3 times x, or 3x for the blue section, and 3 times 4, or 12 for the green section. Another way to think about this is to find a common factor and use the distributive property. So in the expression 3x plus 12, you can separate each of those terms out by finding a common factor. In this case, the common factor, or greatest common factor, you might remember that's called the GCF, of 3x and 12 is 3, because 3x can be rewritten as 3 times x, and 12 can be rewritten as 3 times 4. So you'll notice here that you have a common factor, and that common factor is 3. So now we're going to use the opposite of that distributive property, and we're going to pull that 3 out in front of those parentheses, and then we're going to group together the terms that are left, the x and the 4, and add them together. So we're taking our expression apart, okay? So that's what you see here, and we write it as the product of those two factors. Now let's take a look at the try it question. Use factoring to write an expression for the length of the pool with the given width. So here's what we know. We know the width of that pool is 4 meters. And we know the area of the pool is length times width. Okay, that's the area. So we need to know what this number could be here. So let's take a look at the expression for the pool itself. Okay, we have two parts. We have this part that's blue, and then we have this part right here along the green side. Okay, so what you might notice is that we have 4 meters times x gives you the 4x, and then 4 times what gives you 20? Well, that side has to be 5, that piece. So the entire length of the edge of that pool would be x plus 5 more. There's the x, that comes from the term 4x, plus the 5 from 4 times 5, which is the 20 here in the green section. So what we're essentially doing, again, is taking this expression apart. We're going to rewrite that 4x and the 20 using a common factor. In this case, both of them could be written as 4 times x and 4 times 5. So that means the 4 comes out front, and then the x plus 5 stays in the parentheses. So essentially what we're doing is we are undoing that distributive property. Okay, we're taking those terms back apart and then using parentheses to group them together. The factor they have in common is what comes out front. So if we look to fill in the boxes that you see there in the try it, the number outside those parentheses would be the number 4. And then inside the parentheses, you would have x plus 5. So the length of the pool is actually x plus 5 meters. That's that side of the pool right here. Now let's go on to example 2. Example 2, factor expressions with negative coefficients. Rodrigo and Jordan each factor the expression negative 2x minus 6. Who factored the expression correctly? So let's use Rodrigo's factors first. It says Rodrigo uses a positive common factor, 2, to factor the expression. So off to the side here, I'm going to take my expression 2x minus 6, and I'm going to pull out a 2. Let me change the color of that. Okay, let's try red. There we go. Let's pull a 2 out in front of each of those. Now we're going to determine what do we need to multiply times that 2 to get each of those terms. Well, 2 times what makes a negative 2x? That has to be a negative x. Minus 2 times what makes 6? In this case, 3. So when I pull the 2 out in front of those, the stuff inside the parentheses still has to be all the terms that are left. In this case, a negative x minus 3. Okay, and you can see that over here if you take a look at Rodrigo's area model. Here is his positive 2 factor, and then here are the remaining factors that would go inside those parentheses. So when Rodrigo factors a 2 out in front, he gets 2 times negative x minus 3. Now, if you apply your distributive property back to that expression, you do get negative 2x minus 6, which is what he started with. Now let's go over and take a look and see what Jordan did. Jordan uses a negative common factor. In this problem, he takes out negative 2. So when he factors out a negative 2, let's see what's left. He did negative 2x minus 6. And he takes out negative 2. And what are we multiplying that negative 2 by? Okay, we are multiplying it by x to get negative 2x. And what do we multiply negative 2 by to get 6? In this case, it would be a negative 3. Now remember, there's subtraction between those two. Now this one looks a little bit tricky because when we pull the negative 2 out in front of those parentheses, we have to look at what's left. The x is left from the first term, and we have subtraction and a negative 3 left from the second term. Well, remember, subtracting a negative is the same as adding its opposite. So when we factor the negative 2 in front, when we pull that part of the term out, what's actually left is positive x and a positive 3. So Jordan's expression, when he factors it, is negative 2 times x plus 3 in parentheses. So both of these expressions are equivalent, which means Jordan and Rodrigo are both correct. Now we're going to try the same thing in this try it question. The expression is negative 4x minus 28. So the first thing I'm going to do is start with that expression. And it asks us to do 2 different ways of factoring. So what I want to do first is I want to pull out a positive 4 factor and a negative 4 factor. So think about what you would multiply times 4 to get negative 4x. And you need the negative sign on the x there. Minus, what am I going to multiply times 4 to get 28? In this case, 4 times 7 is 28. Oops, hang on a second. Messed that up. Let's try that again. So I need the 4 times 7. There we go. So now when I rewrite this, I get the 4 out front, and inside the parentheses, I have the negative x minus 7. Now let's do the same thing over here with a negative 4. Okay, negative 4 times positive x minus, and then I need a negative 4. What am I going to multiply by that negative 4 to get the negative 20, or to get the 28? I need a negative 7. So when I do that times negative 7, then my negative 4 comes out front, and I have x minus negative 7, which is like x plus 7. Sometimes what I find it's easier to do is to change the subtraction in the expression to adding the opposite, and then I can go ahead and find those common factors. We'll do some more practice with this in just a moment. Now let's take a look at example 3. I'm just going to move my paper up a little bit here. We're going to make this a little bit bigger. So factoring an expression that has more than 2 terms isn't any more difficult, it just requires more steps. So now we have to consider all 3 terms in that expression and find the greatest common factor for each of those terms. So take a look at example 3. Use the GCF to factor the expression 6x minus 18 minus 12y. So look at the expression first and the term 6x. Well, the factors of 6 are 1, 2, 3, and 6. The factors of 18 are 1, 2, 3, 6, 9, and 18. You'll notice that they both have a 6. And the factors of 12 are 1, 2, 3, 4, 6, and 12. So since each of them has a factor of 6, the greatest common factor is that factor 6 that we're going to pull out in front. Now we're going to use the greatest common factor and that inverse of the distributive property to undo each of those terms. So what happens is 6x, we're going to pull it apart into 6 times x. We're going to take that 18 and we're going to pull it apart into 6 times 3. And the 12y, we're going to pull apart into 6 times 2y. So each of those parts has a factor of 6. That factor of 6 is what comes out front. And then you'll notice that the x and the 3 and the 2y are what go inside those parentheses. And the operation stays subtraction between them because that's what it was in the original expression. So when I look to factor 6x minus 18 minus 12y, I get 6 times x minus 3 minus 2y, and you have parentheses around those 3 terms. So now what we're going to do in the try it is we're going to try to do that same expression, but this time it wants us to factor using a negative factor. So instead of factoring positive 6, let's factor a negative 6. Now this is where it might be easier to go ahead and take that 6x minus 18 minus 12y and let's write it using addition. Okay, so let's write it as 6x plus negative 18 plus negative 12y. Now when we factor out that negative 6, you'll notice how that affects the answers. So negative 6 times negative x is what gives us a positive 6x. And negative 6 times 3 is what gives us negative 18. And then negative 6 times a positive 2y gives us a negative 12y. So what do you notice about the terms in this factored expression compared to what you got up here in step 2 of example 3? Did you notice anything? Well, what you should notice is that the terms are exactly opposite. So when I pull out a negative 6 factor instead of a positive 6 factor, every term inside those parentheses becomes its opposite in order for those two to be equivalent expressions. Now let's try some work together on the next page.